Hello! In this video, I will be introducing you to our Prosthetic Arm Engineering Project. In this project, your goal is to design, engineer, and modify a prosthetic arm for Layla, which is the young girl who lost her arm in an accident. Your goal is to create this prosthetic that replaces the structures and the functions that were lost in her accident. This arm will be tested for certain criteria, and at the end of your design process, you will write an engineering report explaining your process and your results. Now let's talk about the criteria and constraints of your engineering project. Criteria are things that your engineering design must be able to do. For this project, your prosthetic arm must be able to pick up olives. So Layla wants to be able to eat with her family, so the arm that you create for her must be able to pick up olives, which in this case will just be small crumpled pieces of paper. It also must be able to carry a bucket of water 2 meters, which is about 6 feet. For the water, we will use a 2-liter bottle of soda filled all the way up and placed in a bag. Finally, it must be removable and reusable, meaning she must be able to put it on and take it off to sleep and shower and other things and put it back on and use it again. And it must also be comfortable for her to wear. The constraints of your design project are as follows. The amputated hand cannot be used. That means that when you slide the prosthetic over the missing arm, you cannot use the hand on that arm to operate the arm. You also may not use the other hand, the non-amputated hand, in the function of the arm. So you cannot use your other hand to pull things or push things. It must function on its own. And finally, only simple materials that are either provided by us or found by you can be used. That leads us to our available materials. In this design project, you will be given a list of materials to make use of in your design. Those are duct tape, popsicle sticks, straws, rubber bands, string, a solo cup, which is just a plastic cup, cardboard, and you have the option to find other simple materials in your home or for purchase that you may use to add to your design. Once you have designed, built, modified your arm and are happy with your final prototype, it will be tested to see how well it meets the criteria of the project. This will include how well it picks up those olives, if it can carry the water the required distance, and how easily it's removed and put back on, as well as its level of comfort for the wearer. Now let's take a look at the rubric that will be used to test your prosthetic hand. The first factor that will be tested for your prototype is the ease of use. Here, we will time how long it takes you to put the prosthetic on and remove it. To get a 3, this process should take between 6 and 10 seconds. To get a 4, this should take less than 5 seconds. The next component that will be tested is the function replacement. So, to get a 3, your prosthetic should be jointed, meaning that in the fingers there should be joints. We know that Layla lost the structure and the function of joints in her hands. So first, your prosthetic must be jointed. It also must function only with the damaged arm, meaning you slide it onto the arm that is being used to test it, and you do not need to use the remaining arm to operate the arm at all. But for 3, your appendage does not automatically reset, meaning when you bend the joints, they do not automatically pop back. For a 4, you will hit all of these components for a 3, but your appendage will automatically reset. Again, that means that when it is bent, it automatically resets to its original position. Next, we will look at the fine motor control. This is related to Layla's ability to handle food with the prosthetic. So in this, you will be asked to move 5 olives, which remember we will use crumpled up paper balls, from one plate to another. If If you are able to perform this task in under 60 seconds with a little amount of problems, meaning you don't crush the olive, it doesn't fall off the table and roll away, you will receive a 3. If you can smoothly and easily perform this task of moving the 5 olives in less than 30 seconds, you will earn a 4. Next, we will look at your strength and durability. This will be tested by the ability of the appendage to carry the water that Layla needs to carry. To get a 3, you will be able to carry the 2 liters of water in a bag for the 6 feet distance with minor damage during the test. Your prosthetic still remains usable after carrying the water. For a 4, your prosthetic will show extreme strength and durability by carrying that water without any deformation or damage to the prosthetic. Finally, you will be rated on the comfort of the prosthetic. You will reflect on the level of comfort that the prosthetic has for the user to wear for either several hours for a 3, or if you believe your prosthetic is comfortable enough that it could easily be worn all day, you will earn a 4. Your score will then be added for all of these categories, and if you score between 15 and 16 points, you will earn an overall 3 in the engineering design. If you score 17 points or higher, you will earn a 4 on the engineering project. Finally, once you have engineered, built, and finally tested your prosthetic using the rubric we just discussed, you will write a report that will outline all of the following. First, you will review the criteria and the constraints of the project. Next, you will discuss the structures and the functions from both the muscular and the skeletal system that Layla had lost in her accident. You will also discuss how your prototype, the prosthetic that you designed, replaced these structures and functions that Layla had lost. Finally, you will reflect on how successful your prototype was at meeting the criteria of the project. We are so excited to see the designs that you come up with and how you are able to solve this huge problem for Layla.